Hello and welcome to Mathematics Made Easier channel. This is your favorite mathematics tutor, Comfort Amwakon Atta. Today, we are going to look at angles. So relax, pick your jaw test as we go through today's class together. For those joining us for the first time, you are welcome. And if you are yet to subscribe, please look down there and click on the subscribe button to subscribe. And you also click on the notification bell to receive updates all the time. Thank you. Now let's go to our business for the day. Angles. Now let's draw something over here. So study what I've drawn. I'm going to ask you questions on it. Point B and point C. This is a ray, this is another ray, and this is a point. Okay, so this is an angle. What can you say about this angle? Excellent. Now let's discuss it together and compare it to what you wrote about what an angle is, or some features of angles. The first I'll talk about here is looking at our diagram over here. We can see that we have a ray here, then another ray here. So we have two rays. So the first point I'll make here is an angle consists of two rays with a common point. This is a ray and this is another ray, all meeting at a point. So let's write an angle consists of two rays with a common end point. Okay, so that's the first features I can see. What again can you see? Yes? Okay, we can also say that the common endpoint, is called, how do you call this one? Okay, it's called the vertex. The vertex of the angle. Okay, so we have, it means that we have this as a ray. This is a ray. This is another ray. And they are meeting at a common point called the vertex. Okay. What again can you say about this diagram, about this angle? Yes? Okay. Now from this diagram, we can say that an angle can be named by point vertex. Okay, so you can name angles by point vertex point method. So for example, we have angle, looking at this, we can say we have angle BAC or angle CAB. Always the point where the meeting point is should come to the middle. So we have angle BAC or angle CAB. So you can name angles by point vertex method. Okay. So let's see another one too. An angle can be named solely on the vectors. So with this one, we have angle A. That is where the meeting point is. So either you name it this way or that way. So angle A, it can be named solely on the vectors. Okay, let's add the last one to it. Okay, then we can see also that, let's go back to our diagram. This ray is one side of the angle. Okay, so angles are made up of two rays meeting at a common point. Then each ray is a side of an angle. Okay, so looking at this one, we are done. Now let's come to the various types of angles that we have, okay? So types of angles. Types of angles. Yes, mention some of the types of angles that you know. Write them down. Good, excellent, well done. Now look up here and compare your answer to mine. The first type I will talk about is during in our previous lesson, I made some illustrations. When I do this, what did I say it's called? When I do this, you know, this is a ray, this is another ray, and meeting at a point. So when I do this, an angle is formed. A ray, another ray, meeting at a common point. So this is an angle. So with the types of angles, when I do this, an angle that is less than 90 degrees is called great acute angle. An angle which is less than 90 degrees is called an acute angle. An angle which is equal to 90 degrees is called a right angle. Excellent. Right angle. The last one is, when I do this, how do we call it? This is less than 90, 90, then more than 90. So an angle which is more than 90 degrees is called, I'll leave that for you to answer. Now let's come here. The first angle I will draw is, yes, an acute angle. Let's draw it well. Okay. All right, so this is a ray, another ray, meeting at a common point. So we call this an acute angle. An acute angle. So an acute angle is one. So this is an angle which is less than 90 degrees. Which is less than 90 degrees. Okay, so that's the first one. What will be the second one? Yes. Okay, so the second one too is like this. Harriman diagram, okay? Okay, good. And so All right, so we have this one to us, the right angle. So this is a right angle. What can you say by right angle? So a right angle is an angle which is equal to 90 degrees. All right, so the third one we'll talk about here is, yes, I'm waiting for you. I mentioned it, so I expect you to get it right. That is what? The obtuse angle. So we have our level ground. And it's greater than 90, okay? So we have a ray, another ray meeting at a point. Okay, so this is what? An obtuse angle. So whenever you've forgotten or you forget, do your hands. Like, it should be practical, okay? It should be practical. So we can say that an obtuse angle is an angle which is greater than 90 degrees, which is greater than 90 degrees. Okay, the last one I'll add up is, excellent, I heard someone saying it, a straight angle. So what can you say about a straight angle? What can you say about a straight angle? Okay, meeting over here. All right, so when you stretch the ray like this, the angle, what do you think would be the angle? That would be what? 180 degrees. That is half of a circle. So this is a straight angle. Sorry. So a straight angle. So as I said already, a straight angle is a type of angle that is exactly 180 degrees. That is exactly 180 degrees. Okay, so I believe you are following. Good. So now we have 4. We have, what is this? A straight angle. We have, what is this? Greater than 90. How do we call it? Obtuse angle. 90 degrees, how do we call it? Right angle. Less than 90, how do we call it? Excellent, acute angle. Okay, let's continue. The fifth we're going to talk about here is okay, we have a type of angle called a supplementary angle. A supplementary angle. And for supplementary angle, what can you say about it? Good. They sum up to be 180 degrees. Two angles that sum up to be 180 degrees. So we can say that angles A and B are supplementary. So okay, so we have angle A plus angle B as 180 degrees. Okay, let's move on. The sixth one will be, okay, so we have this type of angle. Sorry. So we have A and B. What can you say about this angle? This angle is called a complementary angle. A complementary angle or complementary angles, okay? And what can we say about it? Let's write it. Angles A and B are complementary. Okay. So looking at our diagram for the complementary angles, what can you say about this? Going back to what we said about right angles. Okay, so going back to what we said about right angles, we can say that angle A, sorry, so let's bring some, okay, so angle A plus, okay, angle A plus angle B is equal to 90 degrees because they form a right angle. That is called complementary angles. Okay, so let's move on. Now we come to vertical angles. Vertical angles. So vertical angles. All right, so let's draw this. Okay. Okay. So with our arrowheads, we have A, B, C, and D. Okay, so what can we say about this? So what we can say about this is vertical angles so vertical angles are angles opposite each other, as you can see with this one. They are angles opposite each other when two lines cross. When two lines cross. Okay, so vertical angles are angles that are opposite each other when two lines cross. So it means that from our diagram, we can say that A and B are vertical and C and D too are vertical. They are opposite each other. So let's write them. They are called vertical because, yes, what can you say about it? Good. They are called vertical because they share the same vectors. This one, they share the same vectors. So they are called vertical because they are called vertical because they share They share the same vectors. Okay, all right. So vertical angles are also what? Equivalent. I'll give you some examples and how to solve it, okay? So vertical angles. I want to teach you everything about vertical angles, okay? So as you are learning, you're taking notes. Vertical angles are equivalent. So we have angle C, this side, is equal to angle D, excellent, as well as angle A, also equal to angle B, as I said earlier on. All right, so these are also called vertical angles. They are angles opposite each other when two lines cross. Now let's quickly move to pairs of angles. Pairs of angles. Okay, pairs of angles. Pairs of angles. All right. Let's write something small. So if we have two pairs, okay, so if you are saying pairs of angles, if you have two parallel lines and have a third line, that crosses them, the crossing line is called objective. If we have two parallel lines, okay, so we have two parallel lines like this. Then we have a third line crossing it. How do you call it? The crossing line is called a transversal. It's called a transversal. Okay, so that is our diagram. We have two parallel lines. These are the parallel lines. Then we have a third line crossing them. This third line or the crossing line is called a transversal. All right, so with this one, let's label it. We have A, B, C, D, E, F, G, and H. Okay, all right. So these are the parallel lines. Okay, parallel lines. And this is the transversal line. Okay, the transversal line. Okay, so now let's take them one by one and talk about it into detail. The first we are going to talk about is, now let's pick, sorry. Now let's pick the parallel line, then our transversal crossing. Then we have E, F, A, and B. What can we say about this? What can we say about this? Okay, what can you say about this? These are called corresponding angles. Corresponding angles. Okay, so for this, if we are saying this corresponding angle, then it means that A here is equal to E. So then B also here also equal to F. Okay, so we can conclude that A is equal to E, then B also equal to F. Once again, let's pick the same parallel lines with our transversal line crossing. Okay, then we pick the upper ones. So we have C, D, then H, G. What can you say about this also? This is also what's a corresponding angle. So it means that D is equal to H, then C also equal to G. Okay, so when you see an angle like this or angles like this, it means they are equal. We'll give some examples and you would understand it better. Okay, now let's quickly move to, so let's give an example over here. Examples. I have my parallel lines with a transverse crossing out. Then we have, let's say, 40 degrees. Then we have this side to be 30 degrees. And you have this side too. Okay, so we have A here, and we have Z. So what can we say about this? What will be the value for Z and value for A? From our illustration over here, we can say that Z is equal to 40 degrees. Then also A is also equal to what? 30 degrees. I believe you've understood it. Likewise, the same thing. If I fix a value here, let's assume we fix 60 degrees here, then they are asking us the value for D. It means D would be what? 60 degrees. Please don't forget. Okay, so let's move on. Then we come to the next example. That is, the next type, alternative. Okay, so the next one, I will pick alternate interior angle. Alternate interior angles. Alternate interior angles. Okay, so with this one, so I'll pick the same. We don't bring the arrowhead. It ceases to be a ray. To just be a line. So for the alternate angles, we have F and D. F and D. Okay, F and D. And so we can say that D is equal to F. Okay, D is equal to F. Likewise, the same if we have, assuming we have E here and we have C here, it means also that it will mean also that E is also equal to C. Okay, all right, so that is that for alternate interior angles. So if I'm to give an example over here, so example, let's make the line to be the same length. So Okay, so with this one too, I will decide to fix in here 20 degrees and fix in here 80 degrees. What can you say about this? Then leave this place to be E and C. Find the value of E. Find the value of I, E, I, C. Okay, so from our illustration, we can say that the value of E is what? I'm waiting. Okay, so because the alternate angle, let's fix. Okay, so we fix the 80 over here. We fix our F over here. Okay, so the value of E, so E and F rather, correct it. So the value of E is equal to 80 degrees. That is C is equal to E, or E is equal to C. Anyone goes. Then the value of F2 is equal to what? 20 degrees. That is perfect, and I believe you are enjoying the class. Now we come to alternate exterior angles. Interior is what? Values inside interior. Now we are coming to values outside. So alternate exterior angles. Alternate exterior angles. All right. Okay, so picking our parallel lines again. Okay, so this is exterior, outside, exterior here. So for this, we have H over here, then we have B. So what can you say about it? We can say that B is equal to H. Illustrating this or giving an example under this. Okay, and I give, for example, I give this side to be so 75 degrees. And I ask you to find the value of A. What can you say about it? To find the value of A. Okay, so from the first illustration we did, we can say that A is equal to 75 degrees. Alternate, okay? They are alternating. And so it becomes what's equal. Alternate angles are equal. Then we come to consecutive interior angles. Okay, so as we did, I believe you can look for the other ones too. Pardon my diagram, okay? I expect it to draw very nicely. So if I have, let's say I have the G here, and I have A here. What can you say about it? So as we did for this one, the same thing applies to this side. So we can say that A is equal to G. So the same example, for example, if I fix in here, 20 degrees, and I ask you to find the value for G, what are you going to get? You're going to get G to be twins because they are equal. Okay. Now we come to consecutive interior angles. Consecutive interior angles. Okay. Interior angles. Right. So okay. A para. Then okay, so we have E here and D over here. E and D. So for this, we can say that E, for this, you can say that D plus E is equal to 180 degrees. 180 degrees. The same thing happens when you have so I believe you know angles that sum up two angles that sum up to be 180 degrees as what? Good. I'll leave that for you to answer. So just treated that one too. Okay. So for that one, so we have this place to be F and this place to be C. So what can you say about it? So C plus F is equal to 180. Okay, so give me an example under this. For examples. Okay. So for example, if I have 65 over here, then I have E. And asked to find, then again I have let's say I have 80 over here, and I asked you again to find for the value of C. To find the values of I, C, I, E. What can you say about this? As we said in the illustration we just did, E plus 65 will give us 180. So get your simple change of subjects. You make E the subject to find for the value of E. So 180 degrees minus 65. And what is that one to giving us? Okay, so that one answer is then I part of the question. Oh, this is the I. Okay, then the I part of the question, C plus 80 degrees should give us 180. So C is equal to 180 minus 80. And I believe with this simple simplification, you can find the answer. Okay, let's move to the next one. So I think for this, we are done with the consecutive interior angles. Okay. Then we come to special right triangle. Special right triangles. Special right triangles. Okay, so the first one I'm going to talk about this one. If you have to go back to our lessons, our previous lessons, I proved them for you. So I'm just going to summarize it over here and you go back for the proof, okay? So we have 45 degrees, 45 degrees, then 90 degrees triangle. That's the first we are going to talk about, triangles. Okay, so picking a right angle triangle here, I have A root 2, then 45 degrees, another 45 degrees. And for this, we are going to find the sine, the cosine, and the tangent, okay, of it. All right. Okay. So the first is the sine. What can we say about the sine? Sine is what? I believe you remember. So, okay. So, which is opposite over hypotenuse. Okay. So from the right angle triangle, where is our opposite? Yes, where is our opposite? Our opposite is here. Picking this angle, this will be our opposite. Okay. Then which will be the hypotenuse, this side. Okay. So we are going to take sine 45 degrees. We are going to get opposite over hypotenuse. So opposite of A over hypotenuse. Okay. Okay, so that is a right angle triangle and we've labeled it. So if you pick the 45 from any side, you're going to get the same answer. 45 from this, the opposite will be A. 45 from this angle to the opposite will still be A. So opposite over hypotenuse, A root 2. Then you simplify it to give you, so sine 45 degrees is equal to 1 over root 2. And I believe you know that you can't leave your answer in this form. So go back to our lesson on rationalization if you have forgotten. So this one, you rationalize it. So you're going to get 1 over root 2 times root 2 over root 2. So this will give us root 2 over 2. That will be for sine 45 degrees. Then we come to cos 45 degrees. So looking at our diagram, cos is what? Ka. Ka means what? Adjacent over the hypotenuse, okay? And so looking at our diagram, where is the adjacent? If you are picking 45 from this side, adjacent will be here. So this will be, let's pick it from this side. This will be the opposite. This will be the adjacent. And this will be the hypotenuse, okay? All right, so adjacent over hypotenuse. So A again over root 2. So this will give us A over A root 2. And so as we did for the sine 45, the same applies to this. And you're going to get root 2 over 2. Okay. Then we come to tan 45 degrees. Tan 45 degrees. And I believe we know tan 2 as what? 2. That is the opposite O over A, adjacent. So from our diagram, what is our O? Opposite is A, adjacent is what? A, okay? So we're going to get A over A, which is, simplifying this will give us what? 1. Okay. Excellent. We are done. For the 45, 90 degrees triangle, okay, or 45 right angle triangle. Okay, then we come to 30, 60. So we have this right angle triangle again. And let's label it. We have A root 3. We have 2A. And we have A. Okay. Then we have this is mean that this will prove that's the right angle triangle. And we have 60 degrees over here and our 30 degrees at the side. Okay, so this is 30 degrees, 60 degrees, right angle triangles. Okay. So how do you find for the sine, for the cos, and for the tan? Okay, for the sine, for the cos, and for the tan, how do you find it? And so with this one, if you are picking the 30 degrees first, so sine 30 degrees, what would be sine 30 degrees? Sine 30 degrees. I always want the class one way of doing my things. So you quickly write it somewhere. Okay, opposite over hypotenuse. Good. Now you go back to the diagram. 30 degrees is this one. And so its opposite to be this side. And its adjacent to be this side. And its hypotenuse will be this side. The opposite always depends on where the angle is located. So we have opposite to be A over hypotenuse to be 2A. Okay, so sine 30 degrees. So simplifying this, I'm going to get 1 over 2. And that proves our sine 30 degrees. Then we come to cos 30 degrees. How do you do that? Cos 30, good. That is adjacent over the hypotenuse. And you now go back to the diagram. Where is the adjacent? It is still 30 degrees. Adjacent. Good. Here's the 30. So A root 3 over hypotenuse 2A. So A root 3 over 2A. Then simplifying this, you are going to get that AA cancel out. You are going to get root 3 over 2. That proves our answer for cos 30 as root 3 over 2. Okay, then we come quickly to tan 30 degrees. Tan is what? 2, which is what? Opposite over the adjacent. Opposite over the adjacent, okay? So what are you going to get about for this one too? Where's opposite? Good. A adjacent A root 3. So simplifying this, I'm going to get 1 over root 3. You can't leave your answer in this way. So what do? You have to quickly rationalize this. So this becomes, you multiply both up and down by the root 3. So simplifying this, I'm going to get root 3 over 3. And it confirms our answer for tan 30 degrees. Excellent. Okay, so let's quickly look at all that we've learned. We first of all look at what an angle is. And some teachers that will tell you that this is an angle. So with an angle, looking at my louvers, one ray, another ray, so coming together or meeting at a point forms an angle. So look at the louvers, look at my door, look behind me, the door. The small box over there, one up, one this side. And so when they meet at a point, it forms an angle. The meeting point, as we said, is called a vector. So we said also that each ray is a side of an angle. Each ray is a side of an angle. One point, one ray, another ray meets at a common point, then an angle will be formed. Okay, Then we came to the types of angles. We looked at an acute angle, obtuse angle, and a straight angle. Okay. Then also we looked at pairs of angles. Okay, the pairs of angles, corresponding angle, alternate interior angles, alternate exterior angles, consecutive angles. Then we came to special right angles. For special right angles, we talked about the 30 degrees, 45, and 60 degrees. Please go back and solve more examples on these ones. And I believe wherever you see a question like this or questions under this, you won't find it difficult in answering. I believe this tutorial was helpful. Please, if it was, give me a thumbs up over there to motivate me to do more. Our next tutorial will be on something very interesting and it's promising to be really fun. So keep following this channel and share the links to your friends as well. As I said earlier on, I'm preparing a book for you. That will be Mathematics Made Easier series, MERS series. Okay, simply called MERS, Mathematics Made Easier series. And it's going to help you in your mathematics. Thank you so much for your time. Please do not forget to learn hard and stay safe. Till we meet again. Goodbye.